Hello friends, how are you? I hope you would be fine. Today's my topic is about system call, that what it is. So before moving to my topic, I'll request you to please subscribe my YouTube channel and don't forget to watch my previous videos. So moving to my topic, in computing, a system call, commonly abbreviated to a system syscall, is the programmatic way in which a computer program requests a service from the operating system on which it is executed. This may include hardware-related services, for example, accessing a hard disk drive or accessing the drive's camera, creation and execution of new processes, and communication with integral kernel services such as process scheduling. System call provide an essential interface between a process and the operating system. In most systems, system calls can only be made from the user space processes, while in some systems OS 360 and successors, for example, privileged systems code also issue system call. For embedded systems, the system call typically do not change the privileged mode of CPU privileges. The architecture of the most modern processors, with the exception of the some embedded systems, involve a security model. For example, the rings model specifies multiple privilege levels under which software may be executed. A program is usually limited to its own address space so that it cannot access or modify other running programs or operating systems itself, and is usually prevented from the directly manipulated hardware devices. Example, the frame buffer or networks devices. However, many applications need access to these components, so system calls are made available by the operating system to provide well-defined, safe implementations. For such operations, the operating system executes at the highest level of privilege and allows applications to request services via system calls, which are often initiated via interrupts. And interrupt typically puts the CPU into some elevated privileged level and then passes control to the kernel, which determines whether the calling program should be granted the requested services. If the service is granted, the kernel executes a specific set of instructions over which the calling program has no direct control. That it returns the privilege level to that of the calling program, and that return control to the calling program. The library as an intermediary. Generally, our system provides a library or API that sits between the normal program and the operating system. On Unix like a system, that API is usually part of an implementation of the C library, such as glib that provide wrapper functions to for the system calls. Other named the system same of the system call they invoke on the Windows NT. That API is a part of native API in the NTDDL DLL.dll library. This is an undocumented API used by the implementations of regular Windows API and directly used by some systems programs on Windows. The library's wrapper functions exposes an extraordinary function calling the convention. A subordination call on the assembly level for using the system call, as well as making the system's call more modular. Here are the primary functions of the wrapper is to place all the arguments to be passed to the system call in appropriate processor registers, and maybe on the call stack as well, and also setting a unique system call number for the kernel to call. In this way, the library which exists between the operating system and the application increases the portability. The call to the library function itself does not cause a switch to kernel mode and is usually a normal subroutines call, using, for example, a call assembly instruction in some instruction set architectures. The actual system call does not transfer control to the kernel and is more implementation dependent and platform dependent than the library call, abstracting it. For example, in the Unix-like system, fork and access are C library functions that in turn execute instructions that invoke the fork, and exec system calls making the systems call directly. In the application code is more complicated and may require embedded assembly code to be used in C and C++, as well as require knowledge of the low-level binary interface for the system call operations. Okay, so this is it for today's topic. Time to go. Goodbye. Meet you in the next video.